Welcome back to the Python tutorial series for Climate Mathematics Theory and Applications. In this video, we will finish covering Chapter 2, Basics in Python Programming, with a specialized focus on simple statistics with Python. Let's begin with line 51 that helps generate 10 normally distributed numbers. We will be accessing the Numpy package with the random module, and we will go ahead and go into the random module and access the normal method in order to generate 10 normally distributed numbers. Our normally distributed numbers will have a mean of 0 and a standard deviation of 1, and 10 is our sample size. So your parameters that go into your np.random.normal are mean, standard deviation, sample size. Then upon our print statement, we do get 10 normally distributed random numbers in an output array. Next, we can find the mean of a random sample using the Numpy mean method. We are going to set mean equal to the Numpy mean of the random sample we just made. Then when we go ahead and print, we see that the mean is the output in line 52. Very similarly, we can do the variance of a random sample accessing the numpy.var method with our random sample on the parameter. We could go ahead and print it, and we do get our variance of our random sample. Next, we have a function that can return the standard deviation of that random sample. We're going to access numpy std to be able to find the standard deviation of a random sample. We're going to go ahead and stick our personalized random sample that, once again, that's just 10 normally distributed numbers. And we get a printed SD of the highlighted value. Next, we can do median, also accessing that Numpy package. Basically the same setup as the other ones. You do need a random sample in your parameter. Next, if you wanted to return quantile values, let's say the 0th quantile, the 25th quantile, the 50th quantile, and the 75th quantile, you would have to set up your random sample, which is random, into a Pandas data frame. So the portion of the code that is highlighted right now, we are wrapping our random sample in a pd.dataframe method. This is going to change our random array of 10 normally distributed numbers into a Pandas data frame. This command is accessing the Pandas package, and this is the data frame method. So this portion of the code is truly a Pandas data frame composed of the values of our random sample. Then after we change it into a Pandas data frame, you are going to want to use the .quantile method with your desired array as its parameter. Notice how we have 0, 0.25, 0.5, 0.75, and 1 in our inner array, and this tells the quantile function which quantiles to return back to us. After running our print function on our newly defined quantile parameter, we do get an output that looks like the highlighted text, which tells us that the values in the left column, those are going to be your percentiles at which have the values in the right column. So, for example, your 25th percentile has a value of negative 0.325044. Next, we are going to return the range of the values. Just a reminder, range is the maximum value minus the minimum value. In order to do this, we're going to set our range function equal to the numpy accessing the ptp function. This is a little different than what your intuition wants to do. Just remember that the ptp method does give you the range of values in your random sample. In our random sample, we have a range of 4.97. We can also get the minimum and maximum values for our random sample using the numpy.min method or the numpy.max method. Receiving those two newly defined variables, we have a min of negative 2.2079 and a max of 2.764. Next, we're going to want to plot our random values. We're going to be plotting this in a box plot. So the first thing that we need to do is set up our figure. We are accessing that matplot library .figure method just to help Python understand that we are about to set up a figure. We are going to be using parameter 1 and fig size 8 by 10. Our fig size parameter sets up our outermost box for our figure. Next, we label our AX variable as fig, and we are adding a subplot. Add subplot takes parameter of row, column, index. So having a 111 as a parameter in the add_subplot method allows us to see that we are going to have one row, one column, and the picture that we are putting in it is labeled as our first index. Next, we are going to label our BP as our X with our actual box plot. So the line that is highlighted currently is the actual function that makes our box plot being made on our random sample. Lastly, don't forget to wrap it in PLT show in order for your box plot to actually show on your engine. So we do get this beautiful box plot. Next, we are going to be yielding the statistical summary of the data sequence. In order to do that, we are going to redefine our random variable. This time, we are redefining random with 12 points, 12 random normal points with a mean of 0 and a standard deviation of 1. Next, I am going to define my SUMM, short for summary, as my Pandas data frame on my random sample. So I'm converting my random sample to a Pandas data frame before asking it to describe. This describe function will yield the statistical summary of the data sequence. When we go ahead and print the sum, our newly defined variable, we do get a statistical summary of the data sequence. We have 12 as our sample size, a mean of negative 0.07, standard deviation, min, 25, 50th, and 70th percentile, and your max value is given in this describe function. The describe function does have to be operating on a Pandas data frame, so just take note that you cannot use describe on an array. you do have to convert your array into a Pandas data frame. Next, we are going to be making a histogram of 1,000 random numbers with a normal distribution. We're going to be redefining our random sample as W. We're going to access that Numpy random module, accessing the normal method with a 0 mean, 1 standard deviation, and 1,000 as our sample size. Next, we are going to define hist as our matplot library histogram method with our W, which is our random sample, in as our first parameter, and we are changing some internal parameters, namely face color equals to black. When we finish this block of code with plt.show, we do get this black-faced histogram to appear. We can see visually that it is about normally distributed. Up next, we will be looking at some linear regression and forming a linear trend line. The data that we're going to be doing this on is from 2007 to 2016, and it is data of global temperature anomalies. It can be found on the NOAA Global Temperature website under their Data tab. So, we can see that we do have an import line before our code. We are accessing the sklearn package right here. If you watched the libraries and packages video, you would have learned that this is a machine learning package that helps us train models. So within the sklearn package, we are going to be accessing the linear model module. And within this module, we are going to be importing the function linear regression. Importing a specific function allows us to use this function without preceding it with the package or module name, like we traditionally do. So let's begin. We are setting our variable t equal to the uniformly distributed number line between 2007 and 2016. This line just sets up a year value for every year in between 2007 and 2016. Next, we are setting up our temperatures. We are manually entering some of our temperatures, and we do have 10 temperature values in here to match up with our small t. Our next line, we are setting up our linear regression. This line is quite important. It notifies Python that we are about to train our LM model. Our LM variable is now a linear regression object, so we can train our LM model after the highlighted line runs. With LM fit, we are fitting our little t as our x variable in this case, and big T as our y variable. After we use lm.fit, we do have a fitted regression model. Now we are going to let predictions equal lm.predict on our little t variables, which is namely our year. So what this line is doing is we are inputting our years, which is our little t variable, into our LM model. And our predictions are going to be predicted temperatures that arise from that. We are now going to visually look at our predictions. So we're going to use PLT plot with little t and our predictions. This O notation simply means that we want dots instead of a line to show up on our plot. We have a setting title, we have setting X label, we have setting Y label, and then followed by our plt.show to get our plot to actually show up. Lastly, we will be reviewing on how to input data by reading a file. For reading in CSV files, you do want to set up a variable name file with your path and your file name. Notice that this is a CSV file. We are going to be using the Pandas package and accessing the read_CSV method. We have our file parameter in there with header equals none. This just tells Python that I do not have a header on my CSV file. For text files, we set up our file with our path plus the file name, and we do have a txt file coming in. Rather than using the read_CSV method, we are going to be accessing Pandas read_table method. Same parameters follow. We have our file name followed by whether or not your file has a header and whether or not your file has white spaces as the delimiter. You can learn more about the documentation of the read table and read CSV methods under the Pandas documentation. ASC files are a little bit different than TXT and CSV files. First, you must open your file in read method. That is what this highlighted line is going to do. It is going to open our file, which is our first parameter, in the reading mode. So now I can read this file. Next, I will set up an empty array named data that we are going to be appending to once we retrieve our float numbers. This for loop right here simply goes into our opened file. It will grab each line by line that is in our file. It is going to strip away all of the punctuation and or symbols. Then it will split that line by your delimiters. So our X variable in this for loop is an array of float numbers. Then we go into the inner for loop and access every individual element of our X array, and we append those individual elements to our empty data array, which will allow us to access the data from the file. Lastly, netcdf files are imported in the same way that CSV and text files are imported. We have our file path followed by our data variable. We are going to be accessing the netcdf4 package. Inside the netcdf4 package, we are going to be accessing the method dataset in order to be able to fill our data variable with the contents of the file in read format. This concludes Chapter 2, Basics of Python Programming of Climate Mathematics, Theory and Applications. Join us next time for Chapter 3, Basic Statistical Methods for Climate Data Analysis. Thank you.